Guys, welcome back to the channel. Let's solve another challenge today. So today's challenge is from LeetCode 695, max area of island. So in the one of the previous videos, we solved the number of islands. Similar problem, but the ask is different. We are being asked to find something else. So let's see what we are given. We are given an m by n binary matrix grid. An island is a group of ones representing land and connected four directionally, horizontal and vertical, up, down, left, and right. You may assume all four edges of the grid are surrounded by water. The area of an island is the number of cells with the value 1 in the island. Now we need to return the maximum area of an island in the grid. If there is no island, we need to return 0. So this is a very good example. So how many islands we have here? 1, 2, 3, 4, 5, 6. We have 6 islands. All we need to do, we need to find which island has more ones, right? Let's see the constraints. So we m is the row of the grid, and n is the column of the grid, and m by n, it can range from 1 up to 50. It can be like 50 by 50, and the grid I and j is either 1 or 0, right? Let's see this example in the whiteboard. To really understand this problem, I highly recommend you to go and watch my another video on the same topic, which is LeetCode number 200 problem. And in that problem, we are asked to find the number of islands, right? So let's see what the previous problem was asking, right? We need to start. This is a number of columns. This is a number. This is a rows. What we were asked in the previous video, we need to just count how many islands, right? So the number of islands. Let's say this is we start iterating from the beginning. Let's see the black. So from the 0, 0, right? This is zeros row, zeros column, and so on, right? And 1, 2, and we start iterating from the very first one. Whenever we see the first one, we try to just go all the neighboring cells to see if there are more ones that are connected or as a part of this island, right? So here we have 1 island, right? And 2, 3, 4, 5, and 6. So we cannot count this 2 island as one because there is no bridge between this diagonal, right? We can only go up, down, left, up, down, left, and right, right? We can go only the 4 directions, right? So that is the idea of the previous problem, and this problem is exactly the same thing. How we solved the previous problem, we did the BFS, and whenever we saw, let's say 1 here, we checked if it has more ones attached to this, right? Connected to this one. And if there is nothing, then we just started just moving to the next one, and just we start iterating all the rows and the columns. We see another one. We check if it has more ones connected. Yes, it's connected. Then we just add this one to the queue. Then we go to this one. We go to this one. We check all the neighboring cells, right? Up, down, left, and right, all of them, right? And if they are 0, then nothing. We do nothing. If they are 1, then we just add that as a part of the cell, right? Of the island. So in this case, it's going to be something similar. Here, like how many islands? 1, 2, 3, 4, 5, 6. So we have 6 islands. So in the current problem, we are being asked which island has the maximum area, right? So how we do the area? We just basically count number of ones, right? Here area is 1. Over here area 1 2 3 4, it's 4, right? The area is 4. Here it's same thing, and this island area is 4, and this island area is 5, and this island area is 5, and this island area is 6, right? So what we need to return, so our maximum area in this given grid is basically we need to return 6, right? So again, I highly recommend you go and watch this problem. It's in the graph playlist, and we are going to use same approach. Instead of counting just a number of islands, we are gonna just compute the area of each island, right? Same method we're gonna use because it's more intuitive as a beginning, right? We can use the BFS and with Q, right? That's one way. Or again, to make it similar to this, two is either DFS, recursive DFS, or DFS, iterative DFS with stack, right? Stack data structure. So again, since this problem is continue of the previous problem, I would like to use the first approach, Q with the BFS, right? So how we gonna proceed here? So again, we will initialize Q, right? And we start iterating from the beginning of the array. Whenever we see the array, we check that it's not 1, it's not 0. We check, we only consider the cells in the grid which are the value is 1, right? Then this one, let's say the 0 2, right? We add this one to Q, 0 2 to Q, and this is the initial thing that we found, right? Then we pop this one, pop this from Q, then we check its neighbors, right? We check its neighbors if there are more ones or in either in the left, right, or up and down. We check the boundary because there is this is the edge cell, so there is nothing in the up, right? Because we have to set up the boundary conditions. So right, left, all are 0. So here we record within the queue. This queue is gonna run as a part of BFS function or the method. Then we update this max area. Max area is 1 for this island, right? Then we just keep going. This cell, then we encounter another 1 here. Okay, we start the same process again. This one is basically 1, 1 2 3 4 5 6 7 8, 0 8, right? We add the 0 8 to the queue, right? Then we pop this, right? After we pop, we're gonna add all of its neighbor, right? We check right, we check left, and top is 0. Then we check the down, then we add down, which is 1 8, right? 1 8 to the queue, then 1 8. Whenever we just encounter the cell with 1, this temporary area, we say the temp area, right? Initially, we initialize for each island, we initialize this one to 0. Let's say once we encounter this one, we update this to 1. Then another one, we update this 2. Another one, we update 3. Another one, we update this to 4, right? Then we see this area is bigger than this one. Then we return. Then we update this one to 4, right? This is the area at the end we have to return, right? Then we just keep going. for all the cells. And by the way, again, like as previous problem, once we are done processing this, so that we don't process that again, we need to label them as visited, or we have to initialize, or we need to set them to 0, right? This basically we need to drown this, like we need to put this cell 0. The same thing, we need to put this one 0, all of them after we visit, we need to drown them, right? Then here we come and we return the temp area again for each island. We set to let's say to 0, 0. Then we just go for each cell in this island and increase this one, and then it's 4, and this right now maximum area is 4 from this island, and from this island it's 4, so we do not update. And after we come to this island, right, we see it's returning 5, and we update this one to 5. And the next island is this one, right? This returns 6, right? Because we need to run the BFS for all of them. Then done, we are done with this island. We just keep going. Then finally we reach this one, right? And see, it's returning 5, but we already have the bigger area, so we do not update. So at the end, we need to return this max area, right? So this will be the area that we are going to return. So our steps are very similar to the previous problem. That's why, again, iterate that you just go and watch that problem if you really want to understand this problem, because these two problems are quite identical. In one of them, we are simply counting the number of islands, and this one, we are just computing or trying to just get which island has the maximum area, right? So now let's see the code. Okay, so this is a code. We are being asked to return the maximum area. Initially here we have if there is no grid, we need to return 0 because there is it doesn't have any island, right? Then the next one in here, we need to set the number of rows of the grid, then the number of columns of the grid, and the directions, because for each cell we have to visit up, down, left, and right. So the first one is up, then down, and this one is right, this one is left. Then we need to initialize what is the maximum area, which is the largest area. We set that equal to 0. Then we start iterating, traversing from the first cell of the grid. So for a current row, it's in the range of number of rows, and the current column in the range of number of columns. Then we only start doing this iterative BFS only if the current cell is equal to 1. It has a 1, right? Then we run this BFS function. BFS function, it will receive the argument is we need to pass the grid, because sometimes the entire grid might have only one island, right? That might have a maximum area, right? And the current row, and this is we pass a current column for that to just start iterating, and this will basically return the island area of the specific island. Then we have initially here we have this largest area is equal to 0. Then we need to return the largest area, maximum of largest area, and island area. Initial largest area is 0, so we need to just keep updating this largest area. At the end, we need to return this largest area. Let's see this BFS function. This BFS function. So BFS function is basically, we are, as I say, we are passing the grid and the starting row and the starting column, and we initialize the island area to be 0, right? For each island, whenever we encounter an island, we set that island area is equal to 0. Then we add that cell to the queue, and we then that cell after we add, it means that we visited that cell. Then we need to set that cell value. Initially it was 1. Now we need to round it, right? We need to set to 0, right? So that we don't come back to that cell again. And while this, after we add the queue, while this queue is still not empty, then we increase the island area by 1, because we need to add for each one, right? Then we pop that queue, we set that current row and value. Then for that current row and column, we need to visit its all 4 neighbors: up, down, left, and right. And we need to check if the neighboring row, we calculate this neighboring row is to be the current row plus the delta row, which is like up or down or left and right. Then current column is delta column. Then here we need to check that neighboring row is within the bounds of the grid, and the neighboring column is also within the bounds of the grid, right? Then we need to make sure that that cell value in the neighboring row and neighboring column is equal to 1. Then after that we set that to 0, right? Because after we make sure that that specific cell is part of the same island, we need to round that, right? Or we need to just set that cell value to 0, so that it's we label them as we mark them as visited, right? Then we add that neighboring row to the queue, so that next time it just queue. Then we pop this and to visit more of its neighbors, right? Basically, this queue, after we are done with the queue and queue is empty, we are done with visiting with all of the ones of the same island. Then we return the island area. This island area is basically returned here, right? Here island area is being returned. This island area is being compared with the largest or the maximum area that we are tracking, right? So this will basically do for this problem. So yeah, please go back to the previous problem, problem number 200, to really to see the connection between this problem and the previous problem. So the time complexity of this approach, BFS with Q, is this is a number of rows, a number of columns of the grid times, and the space complexity is going to be the number of rows times number of columns, and Q is it's the minimum of these two, and Q is the area of the largest island, right? In this case is 6, and we need to see what's the column and rows, right? We need to return the space of the this. Yeah, basically this is a space complexity, this is a row time complexity. Yeah, that's it for this problem, and please share your comments and subscribe to the channel, so it will definitely support the channel, and ask your questions if you have any questions. Thank you.